All right, so welcome everyone to the webinar called Taking Root, How Plants Can Help Us Adapt to Climate Impacts. Before we get started, I want to take a moment to respectfully acknowledge that our work at EOS Eco-Energy is done on the traditional and unceded lands and waters of the Mi'kmaq. And today's webinar is the first in our event series called How Nature Can Help Us Adapt to Climate Change. I'll place the link for our event series in the chat box in a little bit in case you're interested in the rest of the things we have coming up this year and want to register for those. The event series has been organized in partnership with the Chignecto Climate Change Collaborative. And if you're not familiar with that, it's a network of professionals working on climate adaptation issues in the Chignecto border region here. So it includes folks from Nova Scotia too. And today's speaker is Vincent Lambert-Song, and he's originally from Quebec. He's a relatively fresh addition to the Maritime provinces. His background is really interesting. It's in agro-environmental engineering, which is a discipline that aligns farming, environmental sciences, and engineering. He has long been fascinated by plant properties and the responsible use of natural resources. So this passion has led him to join the New Brunswick Environmental Network and take the mantle of the BRACE project. He'll tell us a little bit more about that, I think, too. His role is to promote and increase the capacity to use natural and nature-based infrastructure among professionals, governments, and the public as a way for us to tackle climate change adaptation, mitigation, and biodiversity loss and protecting our natural landscapes. So before I turn things over to Vincent, I just want to let everyone know again to stay muted if you can, unless there's some sort of burning question or issue. But otherwise, use the chat box. If you have any questions for Vincent, also use the chat box, and then I'll relay those questions to Vincent at the end. So we'll be nice and tidy and organized. If anybody's listening on the phone, I'm not sure, I will also open things up so that you can ask questions over the phone. So don't worry about that. So thank you so much to Vincent, and I'll turn things over to you now.
Thank you so much, Amanda, for the introductions. I'll share my screen now. So welcome everyone, and thank you for joining me today in this exploration of the power of plants in infrastructure, also known as natural infrastructure. Je veux commencer par dire que bien que la présentation sera donnée en anglais, je vous invite à poser des questions et demander des précisions en français si c'est votre préférence. Vous pouvez écrire vos questions dans le chat, comme Amanda a dit, et nous y reviendrons à la fin de la présentation. So please write your questions and requests for precisions in the chat, and we'll try to come back and answer as most as we can at the end of the presentation. I would like to start by recognizing that I live and work on the traditional unceded territory of the Mi'kmaq, Wolastoqey, and Passamaquoddy people. This territory is covered by the treaties of peace and friendship, which the Wolastoqey, Mi'kmaq, and Passamaquoddy peoples first signed with the British Crown in 1726. The treaties did not deal with the surrender of land and resources, but in fact recognized Mi'kmaq, Wolastoqey title and established the rules for what was to be an ongoing relationship between nations. I would also add an appreciation for the land I grew up in, which is the unceded land of the Huron-Wendat people, and what is now called the St. Lawrence Valley. Natural infrastructure or nature-based solutions are concepts based on landscape preservation, modification, and land ownership, although we are working on borrowed land. We are not the original stewards of this territory we occupy, and we're working on land that has been historically vital to Indigenous people in North America and continue to be to this day. I think it's important for each one of us to reflect on what that means in our own fields of work and how we look at natural spaces. I think it's especially important to reflect on indigenous culture and traditions when it comes to natural infrastructure, because this movement is rooted in us learning to live with the land, to respect it, and to allow it to protect us. I've come to understand that these principles have been known and utilized by the original stewards of this land. So first off, let's get everyone on the same page. The world of natural infrastructure can be pretty confusing. The principles have been researched and adapted in many places simultaneously, and thus there's a lot of overlap in the terminology and definition. So here on this slide, I have all the terminology that are good to know with this field of work. First, starting at green infrastructure, it describes features of the built environment. made exclusively of materials such as concrete and steel, basically human-made materials. And infrastructure includes bridges, dams, water treatment plants, culverts. So everything we're used to thinking of when we talk about infrastructure. And then on the opposite spectrum, we have natural infrastructure, which refers to the use of preserved, restored, or enhanced elements or combinations of vegetation, associated biology, land, water, and naturally occurring ecological processes to meet targeted infrastructure outcomes. So a pretty lengthy definition. Basically, for the sake of this presentation, we'll use natural infrastructure as a all-encompassing term for solutions that use nature to help us and benefit us. Then we have nature-based solutions, which is a very popular keyword, and it describes measures that protect, restore, and sustainably manage natural or modified ecosystem with the aim of maintaining or enhancing services provided to human communities and benefits to biodiversity. An example can be living shoreline practices, no-till agriculture, and urban tree planting. And then we have green infrastructure, which is very similar to nature-based solution, but usually green infrastructure also includes green technologies such as solar panels or passively heated home, which do not necessarily make use of plants, but are green alternatives to what we're doing conventionally. Hybrid solutions are simply mixed between natural infrastructure and green infrastructure together. And low impact development is pretty much the same as nature-based solutions, but specifically it deals with projects that have an effect on water quality and associated aquatic habitat. This might seem like a lot of definition and application of natural and nature-based infrastructure, but the one thing to remember to understand the principles of these approaches is that natural ecosystem provides services that are on par or often even greater than built infrastructure when it comes to human welfare and environmental well-being. From there, we can choose how best to use natural processes to benefit us based on local needs and local conditions. Now, to illustrate the differences between the approaches to infrastructure I presented, we'll go through the gray, natural, and hybrid solution for the same issue, which for this example is stormwater retention. Excess stormwater in urban and residential areas is a common issue. It's usually caused by a lack of permeable surfaces for a given area in the zones of high precipitation and runoff. It is usually aggravated by an inadequate water transport infrastructure for the amount of precipitation. With current climate change prediction here in the south of New Brunswick and Nova Scotia, this issue will only become more and more common. The first solution we can see is the gray solution. So what you can see in the picture is what is called a temporary underground storage for stormwater. It's made of plastic and other synthetic materials. And how it works is that during a heavy rain event, when the volume of water is too great for the capacity of the stormwater system, the water will be sent to these tanks to be stored temporarily. And after the rain event, the tanks will be emptied back into the storm sewers. Now, the second solution uses natural infrastructure principles. Here you can see something familiar, a pond with what looks like a residential area. This is commonly known as a naturalized stormwater management pond. Here, in the event of a rain event, the excess water will be directed naturally to a stormwater retention pond, which you can see here, due to the topography of the land. The water may originally fall on the roof, follow a gutter, run off on the lawn and the streets, and maybe even follow a stormwater sewer pipe, but it will eventually reach the stormwater retention pond. From there, it can take three paths, either slowly seep in the ground and replenish groundwater. It can evaporate from the heat or flow out through a creek. This looks and is a naturalized system. Although it is intentionally placed and managed, it offers the same benefits as a completely natural pond. In this system, plants and microbial life has the opportunity to degrade, absorb and adsorb hydrocarbon contaminants and lawn fertilizer. Sediments will deposit in the pond rather than be transported with the stormwater into local water bodies. This also means that sediment will accumulate in the pond and might need to be dredged every few years. The third solution is the hybrid infrastructure system. The system makes use of both gray and natural infrastructure to cater to specific needs while obtaining many benefits of natural infrastructure. Hybrid solutions can range from mostly gray to mostly natural, and it's a very popular solution. In this example here, we see another naturalized stormwater management pond, but this time there is a mechanical element to it. In this extent, the release flow of the water to a stream that you can see on the left is controlled mechanically by a system of gates. This allows for more control of the stormwater, which could be useful if, for example, there's a flood risk around the stream leading water out of the pond. The mechanical door could then be used to prevent the water flow rate to exceed safe levels in the case of a storm event. And still, most of the benefits of the natural stormwater pond are kept, except maybe the system doesn't allow for fish passage. Now that we know the terms, what does it mean to actually use natural infrastructure to adapt to climate change? Adapting with natural infrastructure means using naturally occurring processes to reduce the impact of extreme weather events and climate change on our infrastructure, health, economy, and environment. One thing we're usually looking for when we talk about adapting to climate change is to physically stabilize our landscape. We want to preserve the landscape and ecosystem we know and benefit from. One thing that gets pointed out from time to time about climate change is that the planet isn't going to die. It will simply become inhospitable for humans. And this is also true on a local and short-time basis. In this part of the world, our economy is based a lot on lumber and other types of natural resource extraction, agriculture, and tourism, to name a few. If our local environments change, we will be greatly impacted. If there's no forests or beautiful beaches and our fields of agriculture are flooded into June and July, how can we sustain ourselves as a province? Also, natural infrastructure creates natural buffers against hazards, and it's a way to reduce the risk to our own infrastructure. Natural environments are designed to absorb a certain type of weather events. For example, wetlands and forests close to rivers can survive and even thrive thanks to temporary spring flooding. Putting the native and natural environment between our infrastructure and the risk is often a good idea. Most of climate change related risks have to do with water. We either have too much of it or not nearly enough. Natural ecosystems such as forests, wetlands, and bogs have the ability to absorb large quantities of water during high precipitation. Even during dry and hot periods, they usually can sustain themselves with the water stored in the soil, at least here on the East Coast. That makes them more resilient than our environments designed by humans. If we can design our environments that we use after forests and wetlands, then we would also be gaining in resilience. The other adaptation capacity of natural and nature-based infrastructure is that of lowering ambient temperature. This capacity is increasingly vital to population health in urban environments, and we'll go more in depth on how plants can cool our ambient environments later on in the presentation. At this point, I want to point out that natural and nature-based infrastructure approaches are well recognized as a solution for climate change mitigation, adaptation, and biodiversity protection. They have been endorsed and used by recognized institutions. For example, in the United States, the US Army Corps of Engineers are great enforcers of nature-based approaches, especially for coastal restoration projects with their Engineering with Nature program. There's also the special report on climate change, desertification, land degradation, sustainable land management, food security, and greenhouse gas fluxes in terrestrial ecosystem made by the United Nations Intergovernmental Panel on Climate Change, which highlights nature-based solutions as an opportunity for climate resilient, sustainable development. And finally, according to the report of the Secretary General on the 2019 Climate Action Summit, nature-based solutions are a realistic and economically viable option for climate action. It provides 30% of mitigation potential and offers scalable solutions to increase resilience and adaptation. If we now zoom in on natural infrastructure, we see how they really work. The key elements here are really the plants and their root systems. Plants have an incredible capacity to interact with their immediate environments and have learned to adapt and thrive in almost any type of environment under almost any type of condition. Going through this cross-section that you can see on the left of this field of cereal crop, from foliage to the soil, we can see how natural and nature-based solution can benefit us and our environment. So starting at the foliage, we're mostly interested in the cooling benefits. The first cooling effect is from leaves of mature trees that provide shade that cool our environment by simply not exposing us to the hot summer rays. The foliage itself also increases the albedo of cities. That basically means that it reflects more solar energy back rather than store it on Earth. And the heat of the ambient environment compared to pavement, concrete, and traditional roofing material is lower. The final way plants cool us is through transpiration. Transpiration for plants is the same as for us. The evaporation of water has a cooling effect and is why we sweat. When plants transpire huge volumes of water on hot days, they also cool the space around them. Now, specific to aquatic and flood-tolerant plants, the foliage also serves as an obstacle to sediment transport and increases the rate of sediment precipitation. This then leads to less sediment accumulation where it's not welcomed and better water quality. Moving down, when it comes to roots, and especially in the Maritimes, we're mostly interested in their capacity to hold and stabilize soil. The network of roots, big or small, in the soil of a healthy forest, wetland, prairie, bog, or crop field even, is what keeps the soil together. This capacity is not hard to accept, and it's easy to see if you ever tried to dig into a soil filled with weeds or transplant a potted plant into a bigger pot. You can really see how the roots encompass the soil together. During heavy rain events, coastal storm or strong winds, the amount of soil eroded away and lost is generally reduced by the plants and their root networks. Other benefits of roots is improving the permeability of the soil by creating channels in the soil and increasing the soil's ability to store water by creating pockets of space. Also, the mutualistic relationship between plants and microbe is most prevalent around the roots. The plants give the bacteria a place to live and provides them with nutrients through its roots. In return, bacteria takes natural chemicals in the soil, such as nitrogen, and turns them into more useful kind of chemicals, such as ammonia, nitrates, and nitrites. When it comes to decontamination, roots intake and assimilate excess nutrients found in farm and suburb runoffs. This plays a great role in reducing occurrences of algae blooms in lakes, which leads to eutrophication or lake death. Plants can also intake or immobilize various amounts of certain hydrocarbons and heavy metals depending on the plant species. This is done through the process of absorption and adsorption, which signify the intake of contaminants inside the plants and on the surface of the plants. And on the surface could also mean on the surface of the roots. Moving on to microbes, they're the key player when it comes to dealing with pollutants. They are an extremely diverse, adaptable, and plentiful group of organisms. If anything exists on this planet and probably beyond it, there's probably a microbe that survives by absorbing it, immobilizing it, and degrading it to another form. They're absolutely everywhere and are essential to plants, soil, and even human health. Basically, microbes will clean water and soils from contaminants, and there's literally a microbe for any type of dirty job. Finally, but not least, the soil serves as the growing medium for the plants and microbes. It also serves as a temporary water storage tank. A healthy and complex soil acts as a sort of a sponge. This capacity is essential to attenuate the scale of flooding events, but for that to be the case, plants must be present and well established already with the soil. Now, there's a good chance that you've walked past a natural infrastructure or a nature-based infrastructure project without knowing it. We in the Maritimes are lucky to have community champions in NGOs and working for municipalities that are passionate about natural infrastructure and have led projects all over the place. As of now, you should have a better understanding of how the principles of nature infrastructure function. Following these principles will lead you to where they can be found. So first off, where water can be found, like rivers, wetlands, coasts, and ponds. As we know, natural infrastructure principles have a lot to do with water management. Most waterways and water bodies close to human infrastructure can benefit from adjacent nature-based infrastructure projects. If not to reduce the risk and the scales of floods and storms, they are very useful to maintain a decent water quality by reducing the sediment load in the water and the presence of contaminants. You can also find them in green spaces such as urban parks, natural parks, and lawns. Green spaces in urbanized areas are an ideal location to manage stormwater while offering recreational space for the population. And finally, you can find them in cities on roofs, walls, and city planters. For cities, the urban heat island effect is of immediate and serious concern. And natural infrastructure projects are usually well received by populations in those spaces. And they're a good way to reduce the ambient temperature at a low cost while beautifying the city. Now that we've been over what are natural and nature-based infrastructure, why they should be considered more seriously when dealing with climate change related risk and how they work, let's talk about the benefits they offer. The list you can see here are general attributes. It's important to note that not every natural infrastructure project is meant to provide all of these benefits, but if planned properly, however, it's not rare that a project can provide all the benefits stated here. Starting at stormwater management, by storing, moving, or infiltrating water, natural infrastructure can be a very efficient way to deal with excess stormwater. With the use of various plants and their capacity to hold soil and filter water, natural infrastructure is also known to increase water quality and reduce erosion. They also replenish the groundwater. In areas with dense agricultural production, a lot of water is needed. For rural areas, that often means digging wells to source the groundwater. The presence of natural infrastructure upstreams of agricultural land ensures that the water will infiltrate the ground and replenish the groundwater downstream. The opposite scenario is that the water will quickly run off on top of the ground, causing flood events, but fails to infiltrate the soil and thus is not accessible for the growing season. If, as predicted, the summer becomes drier in the Maritimes, our dependence on pumping groundwater will grow significantly. Natural infrastructure also reduces the urban heat island effect and ambient heat in general, as we discussed earlier. An interesting aspect is that natural infrastructure usually gains value over time rather than lose it. If properly designed, the ecosystem will gain efficiency over time. The right plants will thrive, the microbes will colonize and form mutualistic relationships with the vegetation, and animals that inhabit the area will participate in the recycling of nutrients. This harmonized system will thus be more efficient at filtering and infiltrating water, dealing with contaminants, and holding the soil in place. When the system is well established, the maintenance will also be less of an issue. This is the opposite of gray infrastructure, which starts at peak efficiency when you build them, but then slowly degrade over time. This leads to an augmenting of the maintenance costs until the infrastructure needs to be fully replaced. In the worst case scenario, the infrastructure might even fail. For example, when a culvert is built, it is made to transport water up to a certain flow rate. The flow rate is based on current conditions and predictions, and the use of a safety factor in engineering means that the infrastructure will also be oversized to ensure safety. But even then, it's often the case that culverts are undersized for heavy rain events, which leads to flooding because the water has nowhere else to go. Thus, it is not a resilient system. It has no capacity to adapt. Another obvious benefit is to biodiversity. Natural and nature-based infrastructure creates habitat to local fauna and flora, especially when using local plant species that benefit native pollinators and other animals. Larger projects like in forest and wetlands and waterway and coastal zones can be key to restore habitat for fish and birds. Aesthetic and recreation can also be a strong incentive for nature-based infrastructure. They offer environments that encourage outdoor activity, tourism, and increase the quality of life and health of local population. And last but not least, carbon storage is a huge benefit of natural infrastructure because the growth of plant matter leads to carbon sequestration. Not only in the plant itself, but over time, the soil too will hold some carbon. As plants die and the biomass decomposes on the ground, part of the biomass will stay in the soil and get buried under the next generation of plant growth and death. It is immobilized there as long as the soil is not disturbed majorly. Next, for the next few minutes, I'll go through into more details on 3 of those benefits: stormwater management, erosion and sediment control, and aesthetics and recreation. These 3 benefits are usually the greatest incentive to adopt natural nature-based infrastructure in New Brunswick and probably for many parts of Nova Scotia as well. So starting at stormwater management. Stormwater management is a huge cost for cities and municipalities. It requires an extensive infrastructure network, and the water that exits said network is usually contaminated by fertilizer, herbicides, hydrocarbons or whatever other pollutants can be picked up by the water on roofs, driveways, and roads. Any natural infrastructure solutions reduce the volume of stormwater municipalities have to deal with, on top of increasing the quality of the water. This is done with water storage in the soil, infiltration in the soil, and transpiration by plants. The key here is the presence of permeable surfaces that allow water to seep into the soil. Transpiration by plants is secondary, but becomes essential to remove the water stored in the ground following the rain. Permeable pavement is another good solution to increase infiltration of water, and a simple gravel driveway can do a decent job. Over time, however, the gravel driveway might become too packed to let water in. Now, one thing that struck me when I moved to Southeast New Brunswick is how much erosion is omnipresent and visible here. From the mud flats I walk past every day to the Hopewell rocks in Fundy, or the sand dunes being pushed and shoved by the wind and the sea. The issue of erosion is most apparent for properties on the coast and along rivers. There's not only does bank erosion represent a net loss of land, but it's also a threat to safety. On agricultural land, erosion leads to major loss of soil fertility. As the rich topsoil disappears with the running water, so does the nutrients. The sediment loss on the land becomes an even bigger problem when it reaches waterways, where excess sediment can majorly alter the dynamics and paths of streams as they deposit. The presence of sediment in the water is also a major threat to water quality and creates an inhospitable habitat for most fish species. By holding onto the soil, plants greatly reduce erosion. On shore, that means having a variety of grasses, shrubs, and trees along the coast. And for agricultural fields, that might mean keeping the ground cover year-round and limiting deep tilling. It might seem secondary compared to loss of land and infrastructure costs, but the aesthetic and nature of natural and nature-based solution is one of its most important features. They create beautiful areas for recreation and tourism, which can majorly impact the local economy. In urban environments, green spaces are also very important for the beauty of the city and the mental and physical health of its inhabitants. The positive impact of natural infrastructure for biodiversity are so essential for recreation and tourism, as they keep fish stocks healthy for sports fishing and provide habitat for birds and bird watchers alike. Now that we have gone through the benefits, we also have to talk about the limitation and obstacles of natural infrastructure. Starting by high-risk areas. Although research and case studies have and continue to favor the implementation of natural infrastructure, it can be difficult for governments and private companies to go outside of the status quo when the stakes are high. For example, coastal roads on eroding banks might be stabilized with rocks or vegetation. But for such a vital piece of infrastructure in a high-risk location, rocks will most likely be used. In cases like this, it's good to remember that hybrid infrastructure is always an option, and that both plants and rocks can be used to stabilize the slope together. There's also cases where natural approaches is simply not appropriate. This could be for sites where vegetation could not be hosted, or a site that needs immediate solution. Natural infrastructure are better suited for prevention than reparation, except in case of restoration of habitat. There's also the low capacity for maintenance. So earlier I said that there's little to no need for maintenance with natural infrastructure compared to gray infrastructure. I didn't lie. The reason why capacity for plant maintenance is one of the biggest obstacles to implementation is that we as humans usually have a very specific idea of what plants we want around us and how we want them to look. Overgrown foliage and unwanted weeds don't really affect the efficiency of natural infrastructure, but they can be an eyesore. We might want to include specific plants that produce food, medicine, helps native pollinators, and look beautiful. These plants might require watering during dry periods. This will increase the need for maintenance, but in this case, it's probably worth it for the added benefits. Being an approach that modifies landscapes and key ecosystems, natural infrastructure projects operate under federal, provincial, and municipal laws and bylaws. A guideline for implementation made by governments would be one of the most useful pieces of documentation to increase the uptake of natural infrastructure, but does not yet exist. Funding for natural infrastructure project is essential to their implementation, both from public and private sources. In most cases, public and private entities favor gray infrastructure solutions simply because that's what they know, but things are changing fast. And finally, natural and nature-based approaches are what we can call holistic or integrated approaches. Because of this, they interconnect with and impact their surroundings in ways that are hard to identify and quantify. Some aspects are measurable locally. Water quality can be measured just downstream of a naturalized stormwater management pond, for example, but it is much harder to evaluate the benefits at a scale of a watershed. It's also difficult to evaluate and quantify the benefits to population health of having more green space in cities, for example. Now, natural infrastructure solution exists for almost any context. Here I'll show a few examples for urban, suburban, rural, and natural settings. First, starting in urban, green roofs are very popular. They make use of usually unused spaces and are a good alternative to conventional roofing membranes. They insulate the roof, treat the rainwater, and can host some agricultural production even. Biosoils are also popular. They're basically planted water transportation channels for stormwater that could replace stormwater sewers. In the suburbs, rain gardens are very popular. They're similar to biosoils, but are primarily meant to infiltrate the water and not transport it. They're a very popular piece of landscaping, and of course, they can be used in urban settings as well, and rural. Then naturalized ponds, as we discussed earlier, create beautiful recreational spaces and improve water quality and deals with excess stormwater. For rural environments, we have terracing and no-till farming. Now, terracing is not a new practice. It's been used for millennia for agriculture in mountainous areas. Some famous examples include the terraces in Machu Picchu in the Andes, or the terraced rice paddies that you can see all over Southeast Asia. But this practice was also popular in Africa and all over Europe, basically almost everywhere in the world that has mountains. Terraces are useful for crops that require irrigation or are in dry areas. They reduce land erosion and water runoff, making the water available for the plant immediately. No-till agriculture is also gaining in popularity. With reduced tilling, the soil in agricultural field is known to hold more water with the more complex soil matrix. The erosion is also reduced, and even greenhouse gases emission from the soil are reduced. Carbon can be sequestered in the soil, but when we till, it aerates the biomass that's in the soil and releases CO2. For natural environments, salt marshes are important buffers to protect coastal infrastructure from storms. And more than that, they are extremely important habitat for many bird species and fish nurseries. And living shoreline, finally, is a coastal restoration technique that makes use of vegetation and dead biomass to stabilize eroding slopes. It's an alternative to rock armoring that preserves some habitat for aquatic and land animals, protects the land from erosion without interfering with coastal sediment transport too much, sequestered some carbon, and of course, it looks way better than a pile of rocks. The future of natural and nature-based infrastructure is very promising. The movement to consider natural environments as vital infrastructure and to implement nature-based solution in landscape is now getting some well-deserved attention from federal and provincial governments. Just this year, a Natural Infrastructure Fund was announced, which promises $200 million for natural infrastructure projects that aim to improve our adaptability to climate change impacts and create more community green spaces. The capacity among professionals to implement natural infrastructure solutions have increased tremendously in the past 5 to 10 years, and many NGOs and watershed groups have applied natural infrastructure principles locally in order to protect their community and environment. The southeast of New Brunswick is especially an area rich with champions of natural infrastructure, such as the Groupe de Développement Durable du Pays de Cocagne, the Shediac Bay Association, and EOS Eco-Energy, to name just a few. And of course, there's my own project at the New Brunswick Environmental Network. The Building Regional Adaptation Capacity and Expertise Project, or BRACE, is an initiative by Natural Resource Canada. It's a program that aims at increasing the ability of communities and practitioners to access, use and apply knowledge and tools on climate change adaptation in their work. There's one BRACE project in Nova Scotia on climate adaptation and 2 other projects along with our own in New Brunswick that do work with woodlot owners and engineers. For our project at the NVEN, we are working with engineers, land use planners, and environmental organizations across New Brunswick to enhance the uptake of natural infrastructure and nature-based solution in adaptation efforts. Our target audience has evolved since then to include the general public and other professionals such as landscapers. The issue we're trying to address is that different sectors often work in isolation from each other when trying to address adaptation challenges. For natural and nature-based infrastructure solutions to be considered and implemented by engineers and land use planners, there needs to be a strong knowledge base, a common understanding of the principles, and a standardized approach. Another key aspect is to help professionals recognize the role of natural ecosystems in providing goods and services for flood mitigation, biodiversity, water filtration, and more when it comes to project planning in order to protect the environments that we still have to this day. For the purpose stated, what we're doing is the following. We are supporting local initiatives that put nature-based infrastructure on the ground and help them share the message of their project. We are building the capacity to implement natural and nature-based infrastructure through education and training. We facilitate knowledge sharing between sectors by hosting workshops among professionals on a local and national level and sharing case study stories. We aim to increase the awareness of the general public because not only can anyone implement their own natural infrastructure project at a homeowner level, but public support can also lead to political action and change in policies over time. I invite you to stay tuned for Adam Cheeseman's presentation on natural infrastructure for homeowners on February 24th. Adam has been an early champion and expert on natural infrastructure in the Maritimes with his team at Nature NB. And the last but not least, we're trying to get a better understanding of the barriers and drivers of natural infrastructure, which is a key aspect to a project. You can find more information on our project at naturalinfrastructurenb.ca. That's where we host our community of practice website. Most of the content we produce can be found there. We share the latest news and studies in the Maritimes and Canada on natural infrastructure. We inform you of any upcoming events on the subject, such as every event in the series. You can find a wealth of case studies on our national map, but we also have video case studies for projects in the Maritimes, some in places that you may recognize. We have a full array of webinar and workshops that were hosted through our project on the subject of climate adaptation, natural and nature-based infrastructure, and natural assets. Other things you'll find on the websites are useful resources and documentation, a place to ask questions, and a directory of professionals working in the field. If you're interested in that content and you wish to connect with professionals and champions of natural infrastructure, I invite you to join the community of practice at naturalinfrastructurenb.ca. I particularly invite you to explore the virtual site tour section of our community of practice if you're interested in local case studies. And I should say that maybe I should drop my email address in the chat after the presentation if you have any questions or you want to reach out. Before I let you go, I want to talk about other examples of plant-based alternatives. Here, I'm not talking about diet plant-based alternatives, but natural and nature-based infrastructure are not the only exciting opportunities to use the potential of plants to solve modern environmental issues or to make human activity less impactful. Here, I'm going to show 3 examples of plants doing the hard work of making our planet inhabitable for us. Starting at phytomining, which is the practice of growing a crop of metal. In practice, this means planting plants that hyperaccumulate the metal that is being mined. Hyperaccumulation is when a plant intakes a certain element or molecule from its environment very efficiently and accumulates large concentration of it in its biomass. The biomass can then be processed to extract the targeted metal. This practice is fairly new, but it's an alternative to conventional excavation mining that is much, much less environmentally destructive. Then we have phytoremediation, which is a much more common technique than phytomining. It's the use of plants along with soil microorganisms to remove, degrade, or immobilize contaminants in a polluted area. It can be used to treat both contaminated soil or water. The most common practice to deal with contaminated soil is to excavate it and to dump it somewhere else, usually in a landfill. That's what we're doing today. And then the area is refilled with clean soil that was extracted somewhere else. Needless to say, this practice is not sustainable, on top of being very expensive. For phytoremediation, willow is often used for its ability to grow fast in contaminated medium. Later, the biomass, the willow, will be harvested and usually burned, which results in a much lower volume of contaminated matter and produces some energy at the same time. The reason this technique is still underutilized is that it takes a much longer time than excavation, as you can imagine, to treat a certain area. Usually, owners of contaminated land want a quick turnover to either sell or build on their land. Then, lastly, we have wastewater treatment using plants, which is also a technique growing in popularity. It's in principle the same as phytoremediation, but for an area that is permanently dedicated to remediation. For this technology, a chosen area will be planted and irrigated with wastewater. Here again, willow is commonly used. The willow will filter the water-soaked soil of common contaminants. It's a great way to deal with volumes of wastewater when the water treatment facility cannot deal with the influence it receives. Here again, the biomass will periodically be harvested and burned. So I hope this short introduction of these three fields of applied phytotechnologies give you a good idea of the absolute versatility and the power of plants. And before we finish the presentation, here are some important points to remember. First of all, natural and nature-based infrastructures are local solutions. That means that they are specific to local conditions and need to be well thought of and adapted to be efficient. The plants used should be native if possible and adequate for the growing conditions. The type of soil should be consistent with what the infrastructure is aimed to achieve and the plants it would host. These are but a few considerations to keep in mind when implementing natural infrastructure. Also, informed implementation is essential. Some natural infrastructure projects can be done with a shovel and two hands, but others require permits, excavators, and trained professionals. Background research on the site conditions and the type of infrastructure to be implemented should be the first step for any project. Natural and nature-based infrastructure are also a great approach to climate change adaptation and mitigation. By using plants, they contribute to carbon sequestration and have a positive impact on many environmental issues that affect us, such as water pollution, erosion, extreme heat. Hybrid solutions are also a great way to include nature and infrastructure. It won't be tomorrow that every sewer will be replaced by a bioswale, every slope will be stabilized with vegetation, and every parking lot will be turned back into wetland. Nor should it be, but it's prime time to design our environments with nature in mind and allow space for as much vegetation as possible in our residential and urban environments. Thank you so much for your attention. I hope this presentation has sparked an interest for natural and nature-based infrastructure for you, or if you already knew about it, has strengthened your resolve to kickstart your own project in the Chignecto region, maybe. I want to thank Amanda Marlin of EOS Eco-Energy for giving me the opportunity to talk to you today, my organization, the New Brunswick Environmental Network, and our sponsors at the New Brunswick Climate Change Secretariat and Natural Resource Canada.